Right, in this question we've got 6 equations and 7 graphs. Now they'll normally give you more graphs or more equations than can match up, but we are asked to match each of these equations up to one of these graphs. Now we should have seen other videos where we've learnt that certain types of equations have certain shaped graphs, okay? So we're going to try and match them up using a bit of logic and what we've learnt before. So having a look at the first one, graph A, we've got y equals 4 minus x squared. Now, that squared, x squared there means that we've got a quadratic, and we know a quadratic, okay, is a curve shape, but we've got minus x squared, so it's got to be up that way. So can we find a graph that is up this way, okay? And here we go. So this one is A because we go up through there, and actually if they asked us, we could say it passes through 4 on the y-axis actually, but we're not asked that, so it doesn't really matter. So this one's A, and I've looked at that, I'm just going to tick that so I don't look at that again. Right, now here we go, we've got a linear graph this time, it's going to be a straight line, and I know that because it's just x on its own, and it's going down that way, goes through 4 on the y-axis, the rise over the run, as we've done before, is it goes along 1 down 2, doesn't it? And so that's got to be this sort of one. All right, so that's B, it's a straight line, so I think it's the only one that's straight, and that's the only equation that has just a single power of x. Now, these ones are getting a little bit trickier, so you don't have to do them in order. The examiner doesn't know what order you do them in. I'm actually going to look at this one, because that's probably the next easiest one. We've got the biggest power of x is a squared, which means it's a quadratic. So we're looking at a sort of parabola that goes like this. So we've got that one, we've got that one. Okay. So can I work out which one it is? Now I can actually, and you should have seen this before. When you factorize something like this, and I'm going to do this, I'm going to factorize that, and x appears in both bits. I get x plus 1. So that means that the roots of this, okay, are 0 and minus 1. So they've got to cut the x-axis at 0 and minus 1. And which one of those cuts at 0 and minus 1? Well, it's that one there, isn't it? So there we go. So I've done that one. Now, can I remember what those 3 look like? Well, this is sort of a squiggle. Okay, is how I think I described it in the video. It sort of goes up and then squiggles and then goes up. Which one of those looks like that? Well, it's not that one, it's not that one, it's not that one. Here we go, here's a bit of a squiggle there. So that's going to be graph C. Tick that one. All right, this is the exponential graph. Now that has, it tends to not, and it almost gets to the x-axis, but not quite. Now, which one's that? Well, that's got 2 bits to it. Here we go. That one almost gets there, doesn't it? So there we go. There's your exponential graph. Now, this one here, the reciprocal graph, is either that one or that one. Now, the reciprocal graph on the video before, we just had this bit. We just had the positive. But actually, if you have the negative stuff, it's round there as well. So there we go. And so you're recognizing the shapes of graphs. You could tell some facts about them. And bear in mind, this one you don't need at all. So that's sort of surplus to requirements. So this one is a parabola, a curve, a U shape, but it's upside down because it's negative. This one's a straight line. We've got the squiggle, we've got the exponential, we've got another one, but I had to find the roots of that. And we've got our reciprocal here, which has 2 bits around there.
So let's have a look at this one. So solve x plus 2x equals 12. So what do you think you do first?
Okay, well I want x on its own, so I would put x equals 12 minus 2x.
Okay, so a lot of the time we want to get x by itself, but what we want to do first is get all of these x's together. So can you see anything we can do with this? Get all these together in one place.
Oh, okay, it's 3x, isn't it?
Yeah,
so
absolutely.
3x equals 12. Oh, and so x equals 4.
Brilliant, spot on, well done.